Well, the first thing to do is a force diagram, so we're going to mark all of the forces on the diagram. So here we've got the tension T in the rope. The block has mass 3m, so weight 3mg. The plank has mass m, which is halfway across. It's a uniform plank, so it has weight mg. At the wall, it tells us that the plank rests with its end against a rough vertical wall. So the plank wants to fall down, so the friction is holding it up, and it would slide into the wall if the wall wasn't pushing it back out. So let's call that the reaction R of the wall. So now let's concentrate on the tan alpha equals 3/4 part. So tan is opposite over adjacent, so 3/4. And we know therefore, with it being 3, 4, 5 triangle, that the hypotenuse must be 5. So we know that sine alpha must be opposite over hypotenuse, which is 3/5, and cos alpha equals adjacent over hypotenuse, which is 4/5. So we've got everything we need now to be able to do this. So show that the tension in the rope is that. Right, so we're going to take moments about A now. The reason we're taking moments about A is that that'll discard the most forces. So we take moments about A, we can ignore F and R because they are distance 0 from the pivot. So moments about A, and what this indicates is that I'm letting clockwise be my positive direction. So let's look at everything that has a clockwise moment about A. So we've got this mg here, which is distance A from the pivot, because the whole thing here is 2A, so half of that is A. So A times mg plus 3mg times x, and then the anti-clockwise moment, take, and now that would be the vertical component of the tension. So this tension has a vertical component, which would be T sine alpha times the distance from the pivot, which is 2A, and we know that all the moments add up to 0 since it's in equilibrium. Tidying that up a bit, so this implies that if we take mg out as a factor, we get A plus 3x, then equals, and sine alpha is 3/5, so that would be 3/5 T times 2A. Just tying up a little bit again, mg A plus 3x equals, so 2A times 3 is 6AT over 5, then times by 5 over 6A, which gives us 5mg A plus 3x over 6A equals T, which is what we were asked to show. And I really should label that part A. So now the next bit, part B. Let's just pop that there. It says the magnitude of the horizontal component of the force exerted on the plank at A by the wall is 2mg. So let us remind ourselves what that means in terms of the diagram. That means that R there is now 2mg. So now if we resolve horizontally, again it's in equilibrium, so the forces going right, which we're treating as the positive direction, are 2mg, and the forces going left are T cos alpha, and we know that that's equal to 0. So that implies that 2mg equals, and T cos alpha would be 4/5 T. So now we've got two simultaneous equations. We've got this here, and we've got this one here. So let's copy this down. Let's copy that and put it down here. So this is our other simultaneous equation that we worked out in the previous part. So we need to solve these two together. So this is our equation A, and this is our equation B. So we can see that T equals that, so let's replace T with that. So that implies that equation A, 2mg equals 4/5, and equation B gives us tension, so we'll replace T with that, times 5 mg A plus 3x over 6A. Those 5's cancel. So let's divide both sides by 2. We get mg equals, and concentrate on the numerator first, we get 2 mg A plus 3x over 6A. Divide both sides by mg. We get 1 equals, and 2/6 becomes 1/3. So 1/3 over 3A, A plus 3x. Multiplying both sides by 3A, I get 3A equals A plus 3x, which means that 2A equals 3x, which means that x equals 2/3 A. So we were asked to find x in terms of A, and that's what we've done. X is 2/3 of A. So next part, so just pop that there. So it says the force exerted on the plank at A by the wall acts in a direction which makes an angle beta with a horizontal. Find the value of tan beta. So again, it helps to look at the diagram. And the force exerted by the wall is a combination of this one here, the wall pushing out, and this one here, the wall holding up the plank. So what we need to do to find out what F is resolve vertically. So if we resolve vertically, all the forces going up. So we've got F plus, and it's T sine alpha, which we found to be 3/5 T. We can replace T a bit later. Then downwards, take mg, take 3 mg. It's an equilibrium, so that's equal to 0. So in the previous part, we've got this equation here that linked tension and mg. So 2 mg is 4/5 T. We've got that just here, so I've copied that down there. So that would tell us that the tension, so times 2 by 5/4. So 2 times 5/4. Relatively easy arithmetic, but I don't want to make any mistakes in an exam, which is 5/2. So T equals 5/2 mg. So now sub that back into our equation here. We get F plus 3/5 of 5/2 mg. Take mg, take 3 mg equals 0. Those cancel, which means that F plus 3/2 mg, and these can be combined to make minus 4 mg, minus 4 mg equals 0. So take 4 mg over at the other side by adding 4 mg, take 3/2. So 4 take 3/2 equals 5/2. So that implies that F equals 5/2 mg. So now we've got the two forces acting at the point A. We've got 2 mg acting horizontally. We've got 5/2 mg acting vertically. So the angle, which the question called beta, is that, and the question asks for tan beta. So tan beta equals opposite 5/2 mg divided by 2 mg. The mg's cancel, so 5/2 divided by 2 equals 5/4. And there we have the value of tan beta, which is what we were asked for. So final part, it says the rope will break if the tension in it exceeds 5 mg. Explain how this will restrict the possible positions of P. You must justify your answer carefully. So if we go back, right up here, we'll see that we've got an expression for tension here. So we're going to use that. So copy that and place it down here. So there it is there. So we know that that's the tension. Well, the tension can't exceed 5 mg, so it must be less than or equal to 5 mg. Now just remember here that this variable x, if we go back up here, x is the position of the box P. So if we solve this inequality for x, we find a restriction on the position of P, we find the value of x, or how it's restricted with regards to this inequality. So let's divide both sides by 5 mg. So we get a plus 3x over 6a is less than or equal to 1, times by 6a, which implies that a plus 3x is less than or equal to 6a, which means that 3x less than or equal to 5a, which means that x is less than or equal to 5/3 a. Therefore, the box cannot be more than 5/3 a away from the wall. Otherwise it snaps. And that's that question. Again, that was quite a difficult one. So very algebra intense, that one. For more videos like this, subscribe to our YouTube channel, and to find out more about our Skype tuition and revision courses, go to alevelmathsrevision.com.